Okay, today we're going to talk about mixture, distance, and word problems. Steps for solving mathematical problems. Identify what you're looking for, give names to the unknown, translate problems into mathematical language, solve the equation, check the reasonableness of the answer, and answer the questions. Now, this is just a suggestion on how to solve it. We all have a different problem-solving technique. Okay, first we're going to talk about consecutive integers. Consecutive integers are numbers that are in order 1, 2, 3, 4, 5, 6. To go from 1 to 2, we add 1, and to go from 2 to 3, we add 1 more, which is 1 plus 1, which is 2, etc. The consecutive even integers are like 2, 4, 6, 8, 10. To go from 2 to 4, we add 2. And to get to 6, we add 2 more, so 2 plus 2 is 4, and that's how we're getting these equations. The consecutive odd integers are 1, 3, 5, 7. Now, most people think odd, and then they think, oh, I'm going to add 1, I'm going to add 3, I'm going to add 5. But to go from 1 to 3, you actually add 2. And to go from 3 to 5, you add 2 more, which is 4. So as you can see, the consecutive even integer formula and the consecutive odd integer formula are the same. So let's try some. The sum of 3 consecutive odd integers results in 45. What are the integers? Okay, so we're going to start with the first integer, the second formula for the integer, and the third equals 45. So I have 3x plus 6 equals 45. Subtract my 6. 3x equals 39. Divide by 3. X is 13. If the first odd is 13, then the second one is x plus 2, which is 15, and the third one is x plus 4, which is 17. So my 3 consecutive odd integers are 3, 15, and 17. The sum of 3 consecutive even integers results in 60. What are the integers? Well, we're going to use the same formula, x plus 2, and x plus 4, because even and odd consecutive integers have the same formula, equals 60. I'm going to get 3x plus 6 when I combine equals 60. Subtract my 60. 3x equals 54. Divide by 3. X is 18. So if the first one is 18, the second one is 20, and then the third one would be 22. The difference is these were odd integers, these are even consecutive integers. The sum of 3 consecutive integers results in 78. In this case, I want consecutive integers, so it would be x, x plus 1, and x plus 2 equals 78. So I get 3x plus 3 equals 78. Subtract my 3. 3x equals 75. Divide by 3. X is 25. So x plus 1 would be 26, and x plus 2 would be 27. Consecutive integers 25, 26, and 27. Now let's do a twist on it. Twice the consecutive third consecutive odd integer. The third consecutive odd integer has a formula of x plus 4 plus the sum of the first and the second odd integers is 119. Now, because I saw the word sum, I put parentheses. I really don't need this set of parentheses right here, but it doesn't hurt either. 2x plus 8 plus x plus x plus 2 equals 119. 2, 3, 4. 4x plus 10 equals 119. Subtract 10. 4x equals 119. Divide by 4. X is 20. I think this is supposed to be 116, so let's go with 116. 29. So x plus 2 is 31, and x plus 4 is 33. Yep, we're going to have to switch that to 116 if we actually want it to work. Okay, before taxes, Marissa earns $725 by working 52 hours. Her employer pays her time and a half for all hours worked over 40. What is Marissa's hourly pay? Okay, so what I know is she gets 40 hours at a certain pay, which I don't know what it is. And then she worked 12 extra hours for the 52 hours at time and a half, which is 1.5 times that rate, for a total of $725. So 40x is equal to 18x plus 18x is equal to 725. 58x is equal to 725. Divide by 58. X is $12.50. So Marissa makes $12.50 normally. Before taxes, Jim earned $564. He worked 30 hours at regular pay, which I'll call X. He worked 6 hours at time and a half, which I'll call 1.5x. And he worked 4 hours at double pay, which I'll call 2x. So I have 30x plus 9x plus 8x equals 564. 47x equals 564. Divide by 47. X is $12. Jim earns $12 an hour. MCI has a long-distance phone plan that charges $6.99 a month plus 4 cents per minute of usage. Sprint has a plan that charges $5.95 per month and 5 cents per minute usage. When will the two plans cost the same? Well, let's do an MCI and let's do a Sprint. And let's set them equal to each other. MCI costs $6.99 a month plus 4 cents a minute. Sprint costs $5.95 a month plus 5 cents per minute. Let's solve it. Bring over my 0.05x. Bring over my 6.99. Negative 0.01x is equal to 699 minus 595, negative 1.04, divided by negative 0.01. X is 104 minutes. Now, that means they're equal at 104 minutes. What else it means is you can tell which one's better before 104 minutes and which one's better after 104 minutes. Whichever program costs less upfront money, which is the $5.95, is better before 104 minutes. So Sprint is a better plan before 104 minutes. That means MCI is a better plan after 104 minutes. It always starts with whichever one's cheaper up front. Two moving truck companies charge the following. Company 1 charges $35 an hour and 15 cents per mile. Company 2, or B, charges $20 a day and 25 cents a mile. When will both companies be charging the same amount? Well, Company 1 is $35 plus 15 cents per mile, and Company B is $20 plus 25 cents per mile. So I'm going to bring my 25 cents over. I'm going to bring my 35 over. Negative 0.10x is equal to negative 15. Divide by negative 0.10. X is 150 miles. So if my question is when are they equal, they're equal at 150 miles. But remember what I told you in the last question. You can tell which one's better before or after. Whichever one costs you least money up front, which is Company B, they're better before. So Company B, better before 150 miles. Company 1, better after 150 miles. Credit cards are offered, one with an annual fee of $39 plus 12.90 simple interest, and one with an annual fee of $30 plus 14.5% simple interest. When will the first card be less than the second card? So I'm asking when the first card is a better deal. Now I can do this two ways. I can do it as an equal, or I can do it as an inequality, where the first card is less than the second card. Since we've been working with equals, I'm just going to continue with the equals. So it's going to cost me $39, and I have to change this to a decimal. I know it looks like a decimal, but it's not. It's a percent. And then I'm going to change my $30, and I'll change this to a decimal. And I'll bring this over, and I'll bring this over. .1415 minus 0.129 is negative 0.0125x equals negative 9. Divide by negative 0.0125. And x is 720 months. Now that's when they're equal. Now, that wasn't my question. My question is, when is the first card better? Well, the first card has the highest out-of-pocket money, so it's better after 720 months. So card 1 is better after 720 months. Okay, mixture problems. Mixture problems are when you take a portion of item 1 and a portion of item B to get a whole or a total. Normally, I set them up as the portion I'm using of 1 with x, the portion of 2 with the total amount minus x, and then the whole or the percentage of the total. So let's see what we've got here. We've got $15,000 to invest into two accounts. One pays 12% interest, and one pays 4% interest. His goal is to earn $1,350 in interest each year. How much should he invest in each account? Well, he has a 12% account and he has a 4% account. And he wants at the end $1,350. In the first account, I have no idea how much he put in. In the second account, I have no idea what he put in, but I know he had $15,000, and then he put X into the first account. Because of that, I can put the total minus X there. So 0.12X plus 600 minus 0.04X is equal to 1350. 0.08X, move my 600 equals 750. Divide by 0.08. 750 divided by 0.08 is 93.75. Now, don't forget to answer the question, how much was invested in each account? This is what my X value is. My X went with my 12% account, so that's how much went in my 12% account. Then I have to take 15,000 minus 93.75 to find out how much went in to my 4% account. That would be $5,625 went into my 4% account. Let's try another one. Steve has $25,000 to invest in a 4% account and a 9% account. He wants to earn 8% overall interest per year. How much should go into each account? Well, he has a 4% account and he has a 9% account. And at the end, they don't tell me how much money he's going to get, but they told me I want 8% of his total. Unlike the other one, they gave me the interest amount total. I have to figure out my own interest amount total. In the first account, he's going to get X. In the second account, he's going to get 25,000 minus X, because that's how much left after I put it into the first account. So I get 0.04x plus 2,250 minus 0.09x equals 2,000. So I get negative 0.05x, move my 2250 equals negative 250. Divide by negative 0.05. X is $5,000. X was my 4% account. 25,000 minus my 5,000 leaves me 20,000 in my 9% account. They're done very similar. Now let's get away from money. Let's get into coffee and nuts. A blend of coffee is to sell for $9 per pound. It is a mixture of $8 per pound coffee and $12 per pound coffee. We need 50 pounds of the mixture. How much of each coffee should be mixed? Okay, so I'm starting with an 8-pound mixture. I'm adding a 12-pound mixture, and at the end I want a 9-pound mixture. And I want 50 pounds of that 9-pound mixture. So the first one will be X, and the second one will be 50 minus X. So 8X plus 600 minus 12X equals 450. Negative 4X, move that 600 over, equals negative 150. Divide by negative 4. X is 37.5 pounds. 37.5 pounds of the $8 per pound coffee. Hard to put my little L in, I'm missing it all the time. That means 50 minus 37.5 is 12.5 pounds of the $12 a pound coffee. A blend of 2 nuts costs $3 per pound. The mixture is a mix of 6-pound nuts and $1.50 pound, $1.50 per pound nuts for a total of 30 pounds. How much of each nut needs to be mixed? Okay, so I'm doing a 6-pound nut and a $1.50 nut to get a 3-pound nut. I need a total of 30 pounds. So the first one will be X and the second one will be 30 minus X. So 6X plus 45 minus 1.5x equals 90. 4.5x, move my 45, equals 45. Divide by 0.45. X is 10. 10 pounds of my $6 nuts. That leaves me 30 minus 10, or 20 pounds of my $1.50 nuts. Very easy if you keep the pattern going. Distance formula. Distance is either D equals RT, R equals D over T, or T equals D over R, depending upon what we know and what we're trying to find out. Roger and Bill are running a 10-mile race. Roger runs at a speed of 12 miles per hour and Bill runs at 10.5 miles per hour. To even things up, Roger gives Bill a 0.15 hour head start. When will Roger catch Bill? So we want to know when Roger's distance will equal Bill's distance. So we're using the distance formula. We know the rate of Roger's speed is 12 miles per hour. And we know the rate of Bill's speed is 10.5 miles per hour. At the end, we want to know when Roger catches Bill. So Roger has to be my rate that I'm looking for, R, my time that I'm looking for, T. That means Bill has to be associated with this 0.15 hours. And Bill was given T plus 0.15. So I have 12T equals 10.5T plus 10.5 times 0.15, 1.575 Subtract my 10.5 t. I get 1.5 t equals 1.575. Divide by 1.5. T is 1.05 hours. Now, if I put 1.05 hours back in and do 12 times 1.05 hours, that means Roger ran 12.6 miles. We only have a 10-mile race, so Roger will never catch Bill in this race. In a 10-mile race, because it's going to take him 12.6 miles. Okay, another distance one. A car is traveling 40 miles per hour, and 2 hours later, car 2 leaves the same place traveling 60 miles per hour. When will car 2 catch up with car 1? Okay, we're doing distance again. We have car 1's distance, and we have car 2's distance. Car 1 is traveling 40 miles per hour, and car 2 is doing 60 miles per hour. I want to know when car 2 will catch up with car 1. So car 2 is going to be my variable t, and car 1 is going to be associated with that 2 hours. So it has a 2-hour head start, so it's t plus 2. So 40t plus 80 equals 60t. Move my 40. 80 equals 20t. Divide by 20, t is 4 hours. Now let's see if I answer the question. When will car 2 catch up with car 1? I haven't been given a specific beginning point, so all I know is 4 hours later. So 4 hours later. Okay, now it's your turn to practice.